Okay, so now I'm gonna discuss about the task 2 data analysis. So task 2, you measure the 10 cell potential at non-standard condition. Okay, so on the worksheet, you need to report the E measured, which is the cell potential that you measured in the lab. Okay, and then in the lab manual, task 2, number 2, you're supposed to multiply by the instrumental error that you calculated in task 1, but you don't have to do it. Okay, so please skip the data analysis number 2 in task 2. So you just fill out the observed E cell, and then you need to calculate the E naught cell. So the standard condition cell potential using the reduction reaction for the 10 cell. Okay? And then after that, you need to calculate, which is it's called the E cell. This E cell is different from E naught cell. So this is the cell potential at non-standard condition. And how do you calculate is that you need to use the Nernst equation. Okay? So Nernst equation is in the lab manual, which is E cell equal to E naught cell minus 0.05916 over N log of concentration of the anode over cathode. Okay, so if you use a 0.05916, you have to use the cell potential in volts. But if you want to use the cell potential in millivolts, this has to be 59.16. Okay, so you can use either way. Okay? So I will use the example to calculate the E cell. So let's say the copper and zinc. Actually, let's do the silver. Okay, so the copper has the E naught is 0.34. Okay, and then silver has, you need to look at the table, and which is 0.8. Okay, so both of them are positive, but this one is lower than the other. So the E naught cell is gonna be 0.80 minus 0.34. So the E naught cell total is gonna be 0.46. Okay. So this is how it goes to here in the Nernst equation. Okay. And then number of the total electron for the overall redox reaction. So if you look at the reaction for each one, copper has 2 electrons, but silver has 1 electron. Okay, but so overall in the one redox reaction it's gonna be 2. So the N will be 2. Okay, and then which one is anode and which one is cathode? Okay, so the according this one is copper is oxidation, silver is a reduction. So the oxidation, this one is anode, and the reduction here is a cathode. Okay. So the concentration for the anode is, you remember you use a 0.1 molar. Okay, so the copper is a 0.1. And also silver is 0.1 as well, but silver has only 1 electron. And then when you write the whole overall redox reaction, it's gonna be 2 silver. Okay, so this one is gonna be 2. So for other combination, for example, copper and zinc combination, you don't have to do multiple by or like square. You don't have to do the 2 because both of them are same electron. But then the combination, that one has the silver. Silver has to, you have to put 2. Okay. And then by the way, so if you have, so then you calculate the E cell, okay? So this 1.46 is gonna be here. And then you calculate the E cell, okay? But for the other, so for example, for the copper and zinc, it's gonna be 0.1 molar, 0.1 molar. So the whole here, the ratio is gonna be 1. And then what's the log 1? Log 1 is equal to 0. Okay, so the whole thing here is 0. So that means here's 0. So basically, the combination that has the same electron is gonna be E cell equal to E naught cell. So you don't have to do this Nernst equation. Okay, so you just copy, once you calculate the E naught cell using the table, you just write it down the same number for the E cell. Okay, so that's what you're gonna do. And the last thing you need to do is that you're gonna do the percent error, E calculated, E measured, divided by E calculated. So please look at the lab manual, page 125. Okay, it's a simple algebra, so you can do it.